Hello and welcome. In this video, we'll explore how to create a stackable surgical guide for a case involving immediate implantation with immediate loading without bone reduction. For this case, you'll need the initial STL surface aligned with DICOM data, the STL model of jaw with virtually extracted teeth, and the STL file of the provisional construction. It's also assumed that the implants and fixation pins have already been placed. Now select the initial STL and open the Surgical Guides section on the right. Click Stackable Guide to activate the step-by-step design workflow. Step 1. Base Guide Setup. Start by defining the guide contour. Place markers along the surface to outline the guide's boundaries. Double-click to complete the contour, then refine it by moving the points. Next, define the path of insertion by rotating and adjusting the guide position to minimize undercuts. On the workflow panel, set the design parameters: offset from teeth or tissue, base guide thickness, fixing guide thickness, side angle defines the angle of the vertical wall cut. If needed, enable the smoothing option to refine the guide surface. Once the settings are adjusted, click Next to proceed to the following step. Step 2. Configuring the guide shape and reduction plane. Start this step by setting the height of the fixation base on working panel. Next, configure the reduction plane, which is displayed in purple in the visualization windows. In this case, the reduction plane serves as the division boundary, defining where the guide separates into upper and lower components in the stackable design. Position it to define the level and optimal thickness for temporary construction placement. Adjust the plane in various viewing windows using interface control elements for movement and alignment. Configure the plane symmetrically relative to the occlusal surface, avoiding tilting. Then, adjust the posterior wall of the blue parallelopiped to ensure the correct configuration of the guide. Move to the next step. Step 3. Osteotomy guide and prosthetic design setup. Since reduction is not required in this case, deactivate the bone reduction checkbox. Set the main parameters for the osteotomy guide, select the surface for which the guide will be created, choose the guide type, solid or bar supported, and specify the thickness and offset. Next, go to the prosthetic section, where select the base type for the temporary prosthesis and choose the corresponding STL file from the list. Click the Next button to proceed to the following step. If you need to return to the previous step to make adjustments, use the Back button. In the fourth step, the guide design is adjusted relative to the placed implants and fixation pins. Begin with the Implant Parameters section on the Workflow panel. Set the sleeve support diameter, the handpiece contact area diameter. Define the sleeve safety zone height and the offset from sleeve. Proceed to the Fixation Pin Parameters section. Similarly, configure the support diameter, handpiece contact area, safety zone height, and sleeve offset. After configuring the parameters, proceed to fixation pin placement if needed. Click the Place Fixation Pin button to activate the mode and open the element library. Select the desired pin type. Then, left-click on the guide area to position it. Adjust the element by moving or rotating it to achieve the optimal trajectory. Proceed to the lock placement stage. Click the Place Lock button to activate the mode. In the library that opens, choose the desired lock type. If needed, expand the library by loading additional elements from the server. Left-click on the guide surface to position the selected lock. You can combine several lock types to achieve the desired result. Reactivate the mode, and select another element from the library to position it on a different surface area. Finalize the setup by adjusting the position and orientation of each lock. Hold the left mouse button to move it along the surface, and use the scroll wheel to rotate. If needed, remove a lock with the right mouse button. Step 4 is complete. Step 6. Temporary cylinder area settings. Configure parameters for multi-unit abutment temporary cylinder holes around the abutment axis. Step 7. Placement supports on the prosthetic. Begin with the support bar configuration section on the workflow panel. Select the bar type and specify the diameter parameter. Proceed to the visualization window to begin bar placement. Click to set the first anchor point at the desired starting location. Click again to set the second anchor point where the bar will attach. The bar structure is automatically generated between these 2 points, creating the support connection. After placing a bar, adjust its geometry as needed. Use the mouse scroll wheel to modify the bar diameter in real time. To remove, right-click directly on the element. Continue placing additional support bars at all required locations. Once all support bars are correctly positioned, click the Proceed button to confirm and lock the current bar configuration into the design. Alternatively, use the Clear button to remove all placed bars from the guide and reset the workspace if a complete reconfiguration is needed. Step 8. Viewing windows, supports, and label. At this stage, install additional design elements. Viewing window installation. Activate the revision window mode by clicking the corresponding button. Select the desired shape and specify the diameter parameter in the configuration panel. Proceed to the visualization window and place the revision window at the required location with a left mouse click. Adjust the position or diameter as needed using mouse controls. Additional support placement. Add support bars to reinforce the stackable guide structure if additional stability is needed in specific areas. Activate the support placement mode and configure the necessary parameters. Enable the label placement mode. Specify the label text and depth parameters in the settings panel. Place the label at the desired location on the guide surface. Adjust text size using the mouse scroll wheel. Configuration here is done. The 9th step provides a preview of all generated components before final commitment. Review the complete stackable guide system in the 3D visualization workspace to verify all configurations meet the surgical planning requirements. If adjustments are needed, use the back button to return to the appropriate step. When satisfied with the result, click Move to Project to export the guide to your project workspace. This operation requires 3 export credits. Now let's examine the workflow variation when using a bar-supported osteotomy guide instead of the solid type. If you select the bar-supported osteotomy guide option in Step 3, an additional step appears in the sequence. Step 5. sleeve support bar installation. This step enables the creation of a framework structure supporting the implant sleeves. Configure the necessary parameters and place support bars at the required locations. Once all sleeve support bars are positioned, click the Proceed button to confirm the configuration and advance to the next step. Review the preliminary results, then click Move to Project to finalize the guide creation process. After generation, guides appear in the project list. Rename guides or change their colors to easily identify and organize multiple elements in your workspace. The generated guide design can be further refined. Click the Edit button to access the built-in editor with advanced modification tools. For example, use the Cut function to remove overhanging edges or protruding sections. Drilling protocols are generated for the base and osteotomy guides. Access them via the View Surgical Protocol button. The protocol provides all essential drilling information. Customize it by adding patient data, clinical notes, and a panoramic view. The completed document can be saved to your PC or printed. As a result of this workflow for an immediate implantation with immediate loading without bone reduction, we have generated a complete set of surgical guides. This set includes the base guide, the positioning guide, the osteotomy guide, and the prosthetic construction. We've also demonstrated two approaches to osteotomy guide design, the solid type and the bar-supported type, providing flexibility for different practitioner preferences.